sketching the addition of functions. So here we're going to take a look at what happens when we take a function and add it with another function and what the resulting function is going to be. We can also do this with the difference of functions going to be identical as well. So taking a function and subtracting it with another function. So this is what our goal is here. So the example we're going to use is what happens if we have f of x equals sine x. We have f of x equal to cos x. Sorry, it should be something different. So g of x. And we'll let h of x equal f of x plus g of x, which is just sine x plus cos x. So let's graph sine x first. So starting at 0. So it's sine x. Let's go ahead and graph cos x. Something like that. Yep, and then now we can go ahead and look at the addition of the two functions. And all we need to do is analyze the y values. So let's make a couple of notes. Whenever we have a function equaling 0, the addition of the two functions is just going to pass through the point of the other one. So for example, here we have cos x equaling 1 and sine x equaling 0 for y. So 0 plus 1 is just 1. So we know that our addition of the function is also going through there. Just as when cos is 0 over here, sine is 1. So we know the function's also going through there. Here, when sine is 0, cos is negative 1, so we know the function's going through there. And using all these same times, every time one of the functions is 0, it's going through the other function. So we know our addition of the function is going through all of these points. When the functions cross over, they both have the same y value. And you can think about, if they both have the same y value, the addition of the functions is going to go through a point that's double the distance away from the x-axis. So we know our function's going through there. Same over here, doubling the distance away from the x-axis. Same over here because they cross, and same over here where they cross. And looking at all points in between, you can think about, for example, a point here where you have this y value and this y value, so we're going to get some higher y value. So it's like thinking about taking this distance for cos x and this distance for sine x, and that distance for sine x gets added on top of cos x, and we know our function's going through here. And we should have enough now to continue the pattern, because we can see that the addition should just be something like this. And that's the addition of sine x and cos x. We're going to go ahead now and do the subtraction of y equals sine x and cos x. So we'll do y equals sine x and y equals cos x, and then we'll look at what y equals sine x minus cos x will look like. So drawing our xy axis. So we'll draw in sine x first. Now we'll draw in cos x. And we're going to look at the subtraction of sine x minus cos x. So what's going to happen is that we can say we have 0 for sine x minus 1 for cos x. So we're going to end up at -1 for the subtraction. If we look at this point here, we've got -1 for sine x and 0 for cos x. So -1 minus 0 is still -1. So we're going through that point. So you can see whenever we're subtracting a 0 value for cos x, it's just going to intersect where sine x is. So all those points where cos x equals 0, we're just going to be intersecting on sine x. So let's mark all those down. So all of those points where cos x equal to 0 is there, and we're intersecting through sine x. Now, whenever the curves cross over with each other, their y values are the same, and whenever we're subtracting y values are the same, we're just going to get 0. So wherever the graphs cross over, we're actually going to be cutting the x-axis, which is all those points there. Now, also, points of interest are where sine x equals 0, because we have 0 minus the cos values, they'll end up flipping the y values for those. So those points, for example, where sine x equals 0 is here. So 0 minus -1 ends up being +1. So we know the curve where sine x 0 is going through there. And over here, where sine x equals 0, we're going to have 0 minus 1. So we're going to be going through -1 there. And sine is 0. Also over here, minusing hasn't lined up well, but that'll go up to 1. And we should have enough to draw out our pattern for the difference of these functions. But if we want to just have a bit of a closer look at this point here. We're taking a y value for sine x and minusing this negative value, which will mean it's a higher up value here for the subtraction of the functions. It's actually going to be whatever this distance is, and this distance will be added on top. So now our function's going through there. And looking at this pattern, we're going to get something like this for the subtraction of the two graphs.